This is a golden gem adding machine. It is a chain adding machine that is actually resettable by turning the knob on the lower right. Now it's called a chain adding machine because of these chains here. If you want to input a number with your stylus, you put it into the chain hole that is next to the number you want to put into, let's say 5, and you pull all the way down. Now to add, let's say we want to add possibly 3 to this. We then put 3 next to the number and pull down, we get 8. 5 plus 3 is 8. Now let's say we want to add 9 to this number. Well, this actually can carry over the 1 in the addition. 9 plus 8 gets to 17. And so it could actually handle these kinds of computations from 0 all the way to 9,999,999, after which it then rolls over. To show this kind of mechanism of carrying over the 1 into the next digit over, let's actually try 999 and then add 1 to it. Now when we add 1, this will obviously carry over into here, but then this becomes full and we have to carry over to here, and then this will have to carry back over into this last digit here. So just by adding 1 to that number, we get all of these turning over and this becoming 1. Thus we get 1,000. So one more example, we'll put actual meaning into these numbers that we're going to give for this addition problem. Let's put in the year that this machine was invented, 1904. So we got 1904 in the display, and I did the math earlier, between 2018 and 1904, that is 114 years. So if we add 1, 1, and 4 for 114, we do get 2018. So this machine could actually do more than just addition. It actually can do multiplication. And if you recall from the days of elementary, multiplication is just doing addition over and over and over again. So we could actually just do this little demonstration by doing 2 times 3. If we add to 1, 2, 3 times, we get 6. We can just clear that off. And we could do this for even larger numbers. We could do 30 times 4. We could do 1, 2, 3, 4. Thus we get 120. And we could even imagine that we have a decimal place somewhere in here. I could have just done 30, or I could have just done 3.1 and kept track of where the decimal was. We could have been doing 120, or this could have just been 12.0. The math works out both ways. We could actually do multiplication with larger digits instead of just doing 2 times 3 and single digit numbers like that. We could actually do a larger number, let's say 682 times, let's say 23. Now instead of adding 682 23 times, there's actually a shortcut we can use, and this was another method that was kind of taught in elementary school, just now it's not on paper. So what we can do is actually we can add just 2 3 times, and I'll get that in. And the reason I only clicked down twice on that was because when we inputted this number 682, we actually already did 1 down swipe, let's call it, on the 2. And so just multiplying by 3, we just added 2 more in there to get to a total of 3 total inputs. And we'll just keep that going over with the 8. We'll add an 8 2 more times, and we'll add in a 6 2 more times. This is 682 times 3. Now to get the 23 in there, we're going to actually do the same kind of method that we did with the 3, but we're going to shift it over a column to the left. This will now move us into the tens region where the 2 is instead of the ones region where the 3 was. And so we'll just do this kind of all over again. We'll add the 2 twice. We'll add the 8 twice. And we'll add the 6 twice. It's just now shifted over a column. And there we have it, 15,686. That is an accurate answer. So this machine can do addition as advertised, and by adding multiple times over, you can do multiplication. Now, with a little neat trick, you can actually do subtraction on this machine. And when I actually bought this, it came with a little guide on how to do that. It read, add to the minuend the complement of the subtrahend. Also, all the nines to the left of the subtrahend. The result will be the remainder. Now that makes no sense. We're just going to go through it in a more visual sense. So what we have here, 16, and let's subtract 4, let's say. And we know 16 minus 4 is going to be 12. So how do we add something to 16 to get 12? Well, that's where that idea of complements comes in. Now the whole thing about complements is that if you take two numbers and their sum equals 9, those two numbers are complements. So the complement of 0 is 9 because 0 plus 9 is 9. 1 plus 8 are complements because 1 plus 8 equals 9. You have 2 and 7, 3 and 6, 4 and 5, and then it just mirrors back over again. And we can kind of see this visually on the machine. If you kind of put a line between the 4 and 5 and you reflect it across that line, you can kind of see the complements there. So we have 0, 9, 1, 8, 2, 7, 3, 6, 4, 5. And this is kind of how you do it. If you add the complement of the number you're trying to subtract away from this, you will end up getting 12. And that makes no sense until you watch this happen. So what I'm going to do is subtract 4 away from this by adding the complement of 4. And we'll just cover that up. Now, if you look closely, I put in the wrong complement. Instead of putting 5, which is the complement of 4, I put in 6. And the reason for that is because the whole 9's complement idea applies to all of the leftmost columns. And it doesn't apply to this one. We actually use 10's complement. The sum of the two digits when they add to 10 are the 10's complement. And so when you have 4 and 5 equaling 9, you actually use 4 and 6 equaling 10. And that will give you the 12. And so what happened when I did that is when I pushed down on the 6, I got my 2-digit here, but then this 1 changed to a 2. That's kind of what happens when you add 16 plus 6. So what they did, what the instructions actually said is to left of the subtrahend, add all the 9's. And pretty much all I did there was just take the 9 to all the leftmost columns and just added them in, just swipe down. And I can continue to do that if I really wanted to get that out of the way. Messed it up. So either way, the whole idea is to ignore the first digit that pops up in this sum, and after that first digit, you will get the right answer. So this whole idea of complements might still be a bit confusing, so we're going to use another example, and we'll do larger numbers instead. Let's go with some 4-digit numbers there. You got 6,749. We're going to subtract, let's say, 500. 524, let's call it. So let's go through this. We will start at the hundreds column and subtract 500 away. But we'll use the complement of 5, the 9's complement of 5 more specifically, which is 4. And then, what did I say, 524, the complement of 2 is actually 7. So we'll bring that down. And then the 10's complement, since we're on the last column here, the 10's complement of 4 is 6. And so we'll bring that down. All the way down. There we go. And then what it wants to do is add all the 9's left of the subtrahend. And so since we were working with 524, the 524 took up these 3 columns here. So we don't add 9 to these 3 columns. Instead, we add 9 to all the ones to the left. And so we'll add 9s all the way to the left. That 7 has now turned into a 1, and then it turned into another 1 until that 1 got pushed off all the way over here, called technically overflow if you want to go that route. And there we have it. Our answer is 6,225. Now the last one is division. And division on this one, it actually doesn't say how to do it in the instructions, but I kind of worked around it and figured out a way to do division on this. Division in the sense of maybe elementary school level where it tells you the remainder instead of getting to decimal points, but it does give you an accurate answer nonetheless. So we can start with a very simple one. Let's say 10 divided by 5. Now, the whole point of division is kind of similar, not similar, it is pretty much the flipped opposite of multiplication. Multiplication is doing addition multiple times, where division is doing subtraction multiple times, in the sense we have to keep on subtracting the same number away until we get to 0, or at least something that is less than the number we're subtracting away. So we have our 10 digit here, and we're going to divide it by 5. So we need to find a way of how to keep track of how many times we minused 5 out of 10. So let's go at it. Let's subtract 5, and the 10's complement of 5 is actually 5. And then we got to add all the 9's. But I'm actually going to stop there, because this 1, instead of pushing it off the display, we're going to keep it there. Because this actually tells us that we did a subtraction of 10 one time. And so now, since we have a 5 here, we can just subtract 5 one more time, and then add the 9's. And there we go. So right now this answer looks like it's 200. But if you read it in a very careful way, this is the correct answer. So our 10 is the number that we started with, and that took up the 2 digits here. And so when you get an answer, these first 2 digits should show the remainder. So we can kind of have an invisible line here where everything to the left is the answer and everything to the right is the remainder. In this case, 10 divided by 5 works out evenly, so we have no remainder and our answer is 2. So let's do a real difficult division problem. Let's try a big number, let's say 2,186. And we'll divide that by another large number, let's say like 824. And so what we gotta do is we gotta subtract 824 from this number X amount of times until we get a remainder of some sort, or it actually divides evenly, which I doubt in this case. So let's get right to it. Let's subtract 824. The complement of 8 is 1. The complement of 2 is 7. And the complement of 4 is 6 when we're dealing with 10's complement. And then we'll add the 9. And so what this tells us is that we've done one subtraction and we're left with 1,372. This is bigger than 824, so we could do it again. Do 1, 7, 6. And then we'll add the 9's over. And so now we have done 2 subtraction problems, and now we are left with 548. This number is actually less than 824, so this is our remainder. So the answer is 2, remainder 548. If you want to put that into a modern calculator, you could do 2 plus 548 over 824, and you'll get your decimal answer out of that.